Okay, we're going to look at acceleration, where A is acceleration, V is velocity final, and V sub I is velocity initial, all divided by time. What does that mean? It means what's my final speed minus what speed did I start at divided by time. Now, sometimes that's zero, so that's easy. Sometimes we are taking our acceleration and we've already been going. Well, like, what is acceleration? Well, acceleration is how fast can I get my car up to speed? So a lot of times on car commercials, they'll say it's an acceleration of 0 to 60 in 5.4 seconds, or 8.3 seconds, or 13.2 seconds. The longer it takes you to get there, the slower your acceleration. The faster we can get there, the faster our acceleration. So what we're really looking at is, let's say I have an acceleration of, let's say, 10 meters per second per second. Well, what does that really mean? Well, this, if you look at it, that looks like speed, right? 10 meters per second. And then I've got this extra time unit here. And that means that every second that increase in time, so on my seconds, after 1 second and 2 seconds and 3 seconds and 4 seconds, my speed is going to increase by 10 meters per second. So what's my speed at each of these time frames? I need to learn to write with this thing. So after 1 second, I'd be going 10 meters per second. And forgive me, but I'm going to put this over here so I don't have to write that unit. After 1 second, I'd be going 10 meters per second. Another second later that passes, I'm going to increase by another 10 meters per second. And after 2 seconds, I'd be traveling 20 meters per second. After another second passes, I'm going to increase by yet another 10 meters, so I'd be going 30. And guess what we get at 4 seconds? Well, 4 times 10 at this point is 40. So that's one way, but let's say that's a pretty easy acceleration. What if I didn't have quite that easy acceleration where it kind of attracts with the seconds? Well, let's try it again. Let's take an acceleration that is 2 meters per second. Still easy math. 2 meters per second, per second. By the way, this can also be written as 2 meters per second squared. Okay? So going back to that same, just doing some basic math, here is my time in seconds, and here is my speed in meters per second. And we're going to increase by 1 second each time. We'll go for 4 seconds again. So after 1 second, we will be traveling 2 meters per second. Now, once another second passes, I increase by another 2 meters, and I have 4 meters per second. Another second passes, I increase by another 2 meters, and that's 6 meters per second. And another 2 added to that next second is 8 meters per second. I'm guessing you're starting to see a relationship between the time and the speed acceleration. If I were to graph that, that's a pretty linear acceleration, right? I don't know if that's perfect, but it's pretty close. I could do it. I suppose I should go through and do this, and we can plot it and see. There's 1 second, and this would be 2. Here's 2 seconds, and that would be, that'd be 1. That'd be 2, and then 3, and then 4. And we'd plot our points. And starting at, of course, 0. And you'll see that in this case, this bottom unit, again, is time, because remember I told you that graphs are really division bars. And we're comparing speed to time. So this side is really speed. So speed is my y-axis and time is my x-axis. This gives me an acceleration graph. Okay, so let's look at our first problem. And just to make sure that we have this so we can see it, acceleration equals, and you should put this on your formula sheet, velocity final minus my initial velocity, or otherwise known as velocity initial, divided by how much time it took to go from that starting speed to the ending speed. So over here, a roller coaster, and this is where it's good to, this is on a piece of paper. You can print this out if you're at home. If you're in the classroom, I probably have copies available on the front, and you are always welcome to do that. But you're going to submit it on Schoology. So if you happen to be doing this and you're not anywhere where you can print something out, or you're not in the classroom where you can get a copy, you can just use a scratch sheet of paper and you can do the same thing that I'm going to be doing here. But the nice thing if you have it printed is you can highlight information. So a roller coaster's velocity at the top of the hill is 10 meters per second. 2 seconds later, there's my time, it reaches the bottom of the hill with a velocity of 26 meters per second. So think this through. What's my starting speed and what's my ending speed? Well, the roller coaster at the top of the hill, so that's my velocity initial. And over here at the bottom, then as it reaches the bottom of the hill, so that needs to be my velocity final, is right there. And now I can just fill in this information. So number one, I'm asking you actually to identify the different parts of the equation. That's why I'm setting it up here. And then you're going to notice that at number 4, 5, and 6, we're actually setting up the equation. So I'm just trying to make sure you're processing through this. So again, we're doing number 1 together, so that should help. All right, velocity final, because that's the first thing you have here, is 26 meters per second. My velocity initial is right here at 10 meters per second. My time was 2 seconds. So see, we filled all that in. So if I were going to write that now, I would have acceleration equals velocity final, 26 meters per second, minus 10 meters per second, divided by time, which was 2 seconds. All right, now we're getting closer. Let's fill that information in. So for what is acceleration equal? Well, what minus what? Final velocity. So you're really using these same things again, aren't we? 26 meters per second minus 10 meters per second divided by 2 seconds. And now we need to calculate that. So if you are using your phone, that's fine, but remember you're only using it for your calculator. Otherwise, calculators are good to have. I have a graphing calculator. A cheaper calculator will work. That's fine. But again, remember we're doing subtraction at the top, so order of operations matter. If you're doing this on a cheap calculator, we're going to take 26 minus 10, which I'm guessing you could have done in your head because you can, well, that's 16, and then hit divide by 2, which I don't really need a calculator. We can figure that out, that 16 minus 10, or sorry, 26 minus 10 is 16, 16 divided by 2 is 8, and in this case, my answer is going to be 8, need the pen, 8. Now, my units here combine to meters per second, right? Meters per second. But I didn't get rid of that unit on the bottom. See, that's also a second. That's a little cumbersome, right? So we know my answer is 8. And the next question is, did it slow down or speed up? Because if it slows down, it's a negative acceleration. And if it speeds up, it's a positive acceleration. Well, if we started at 10 and we went to 26, that's a positive acceleration. So we know this can, I don't have to put a negative there because I know it's positive. But how do I deal with that? Well, ladies and gentlemen, if you remember from math, I can multiply something by something called the reciprocal, right? It would help if I would do an S instead of an 8. So meters per second over seconds. Well, that's also implied that there's a 1 under there. If I multiply by the reciprocal, I flip that, 1 over S. And this is how I'm getting that unit. Now there's 2 ways I can write it. I can literally leave it the way it was and have 8 meters per second and leave the division bars, completely fine. But you're going to notice here that if I multiply through, this ends up m times 1 is m, and s times s is s squared. So the other way to write this, which is exactly the same thing, would be to say 8 meters per second squared. Either one is completely fine. The biggest thing, remember, is to figure out if it's positive or negative. In this case, it's positive. So when I go to fill that in, right here, number 7, it's 8 meters per second. And this is how we do number 1. Now, if you need more help, that's what I'm here for. And I will be happy to go through any of these problems you want. Probably going to put a couple extra examples at the bottom in case you need it. But otherwise, go back and watch the video again and make sure you can work your way through. If that doesn't make sense, go watch the videos at the bottom. I'll go through a couple more problems down there. And if that doesn't help, then my expectation is you're either going to come and see me or you're going to jump on Zoom, depending on what format we're in at the time. And that's acceleration.